Okay, so we're just going to focus on practicing doing identity proofs. So it's important to, again, to know your identities, have your formula sheet with you. Make sure that you are starting to develop and making note of some strategies to be able to deal with some of these identities. Okay, so this one here, if I just cross multiply, you should be able to see that there's a difference of squares here equals cos squared. So we get 1 minus sine squared equals cos squared. That must be true. However, this is something that we shouldn't really be doing. Multiplying both sides of the equation, okay, is not something we should be doing with identity proofs because that relies on the fact that it's equals, and logically we're actually trying to prove that this is equal to each other by showing the left side independently done to the right side. So there's ways around this. So again, one of the strategies is maybe to get a common denominator on left side and right side when we're dealing with fractions. So what I'm going to do here is I'm going to multiply the cosine theta and cosine theta on this side. Okay, so I haven't changed the identity. This is still multiplying by 1. And I'm going to multiply by 1 minus or 1 plus sine theta over 1 plus sine theta. So again, notice I'm multiplying by 1, so I don't change the value of the left-hand side. The left-hand side still remains exactly what we started with. But what happens is we end up with the difference of squares in the numerator, and then we end up with a common denominator. And this strategy of getting a generated common denominator is a very good way to solve identities, because once the denominators match, we only need to focus on the numerator. Okay, in this case, we end up with the identity in the numerator. Now you can change either side of this. I'm just going to change the left-hand side. Okay, so that equals the right-hand side. There's lots of things we could have done here. We could have, canceled. We could have kept that all the same. We could have canceled out the squareds here, and we end up with that identity. There's lots of different variations of this. Okay, but as long as you can make the left-hand expression look exactly algebraically the same as the right-hand side, you've proven the identity. Okay, let's take a look at the next one here. Here we have 1, 2, 3, 4 terms. Here we have a binomial term. So the number of terms don't match. We've got sines and tans and secants and coses all mixed in here. So that doesn't match either. So a few things we could do. I could convert this all to sines and coses. But what I could also do is, so that's one strategy. Another strategy is to match the number of terms. So here I have a binomial, and if I can express this as a binomial, okay, I can then multiply binomial times binomial. Binomial is going to give me 4 terms, which matches the number of terms on the other side. So that is a strategy we can use, is matching the number of terms. So secant squared is an identity. It is tan squared plus 1. Again, we should have our formula sheets out. And I multiply by 1 plus cos. This is going to generate the same number of terms. Well, if I multiply this out, I get tan squared. Well, I have a tan squared matching already. Outside, it's going to be tan squared times cos plus 1 times 1 is 1. There's my 1, so I'm just going to highlight these things. I already have this match. I'm not going to mess with that anymore. I have these ones match. I'm not going to mess with that anymore. And when I multiply the rest of this, 1 times cos plus cos x. Okay, yeah, I have 3 out of the 4 terms already matching. So there's my cos and my cos. Okay, so I'm not going to touch any of those because those were already proven. Those already show that we're the same. So I just need to show that this expression matches that expression. Okay, now I can't just eliminate what I have, but I'm not going to touch those other terms. I'm just going to keep them the same. Okay, and what I'm trying to do is show that those are equivalent. Well, if I rewrite that as sine squared over cos squared, I generate my sine squared, I generate a cos in the denominator, and that cos squared cancels with this multiplier cos. So that's what I'm going to do to solve this then, or to prove this. I get sine squared over cos squared times cos. Okay, those are going to cancel out. and that's going to generate that expression. Okay, just don't forget there's the whole rest of that expression left to solve for. So then I now have left side equals right side. I just need one more step to clean that up. So I end up with sine squared x all over cos x plus 1 plus cos equals the right hand side. The identity is now proven.